September 7th, 2025. Total lunar eclipse. Complete darkness blanketed the Earth. And in that moment of absolute shadow, something from another star system did the impossible. It switched colors. Instantly. From blood red to luminous green. Not gradually. Not over hours or days. In a heartbeat. And when it did, cyanide production spiked 9 times. Industrial-grade nickel flooded into space. No iron. None. Harvard astrophysicists are watching it right now. So is the Pentagon. In just days from now, it disappears behind the sun at the exact point where advanced technology could execute maneuvers we'd never detect. What emerges in December might not be the same thing that went in. Because right now, at this very moment, the object designated 3I Atlas is expelling 150 kilograms of material every single second. Material jetting away with enough force to alter its trajectory. Except its trajectory hasn't changed. Not even slightly. That's mathematically impossible unless this thing weighs 33 billion tons. 1,000 times more massive than any interstellar object we've ever encountered. And here's what nobody is talking about publicly, though whispers echo through observatory halls and government briefings. It sent a radio signal from the exact same cosmic neighborhood 48 years ago. The famous wow signal. 0.6% probability that's random chance. Then it appeared perfectly aligned with our planetary plane. 0.2% probability. Time to pass Mars, Venus, and Jupiter at optimal observation windows. 0.005% probability. You don't win the lottery 3 times by accident. October 29th, it goes dark. Hidden from every telescope on Earth for 51 days. And when NASA's government shutdown happened on October 1st, just 2 days before the Mars flyby that would have given us the clearest images ever captured, the data got buried. Locked away. The high-rise camera has 30-kilometer resolution. It saw something during that flyby. We just don't know what yet, because they won't tell us. Harvard astrophysicist Avi Loeb gives this object a 30 to 40% chance of being alien technology. The scientific establishment calls him crazy, reckless, attention-seeking, but the numbers don't lie. Numbers never do. And that activation event during the eclipse? That wasn't gradual comet warming. That was a threshold event. Like something turned on. Like a switch was flipped. 3 observatories are watching our skies right now for unidentified aerial phenomena activity. Because there's a theory circulating in classified briefings and whispered conversations. A theory that 3I Atlas isn't the threat. It's the distraction. While everyone watches the mother ship, analyzes its composition, debates its origin, what's being deployed elsewhere. What operations are proceeding in the shadows while we stare at the obvious. December 19th, it comes back. Closest approach to Earth. And we're about to find out if physics still works the way we think it does, or if something else has been running the experiment this whole time. Before we go any further into this rabbit hole that might change everything you thought you knew about our place in the universe, I need you to do something critical. Hit that subscribe button right now. This information needs to reach as many people as possible before December. Leave a comment telling me where you're watching from and whether you think we're being watched. And here's the important part. Understanding what's coming requires focus. It requires attention to detail. So if you value truth, if you want to be among the people who actually understand what's happening in our solar system, hit that like button. It tells the algorithm this matters. It pushes this information to more people who need to see it. And for those of you who make it to the end of this investigation, I'll tell you exactly what to comment to prove you went the full distance. The photographs arrived during the early hours of September 8th. Michael Yeager and Gerald Riemann, 2 astrophotographers working from the pristine dark skies of Namibia, had been tracking 3I Atlas for weeks. They chose that particular night with calculated precision. A total lunar eclipse was unfolding overhead. The moon's usual glow, that constant wash of reflected sunlight drowning out faint objects, would be extinguished completely. For a brief window, the sky would be darker than it had been in months. Perhaps darker than it would be for months to come. They pointed their instruments toward Sagittarius, toward the region where 3I Atlas should be visible. What they captured wasn't what they expected. What appeared in their images violated everything we know about how comets behave. The object had changed color. Completely. Every previous observation, every spectroscopic study conducted since the comet's discovery on July 1st, had shown the same consistent result. 3I Atlas glowed with a reddish hue, the kind of ancient, oxidized color you'd expect from an object covered in radiation-damaged dust. Space has a way of turning things red over geological time. Cosmic rays bombard surfaces for millions of years, systematically breaking down complex molecules into simpler, darker, redder compounds. It's the rust of the universe, the patina of deep time. But the images from September 7th showed something else entirely. A bright, almost luminous green, not a gradual shift, not a slow transition as the object warmed approaching the sun. The color change appeared instantaneous, threshold-like, as if someone had flipped a switch the precise moment darkness fell across Earth. Think about that for a moment. Really think about it. Comets don't work that way. When a comet approaches the sun, its surface heats gradually. Predictably, ice sublimates at rates determined by temperature and solar radiation. Gas escapes along pressure gradients. Dust particles lift off as volatile ices beneath them vaporize. The process is continuous, modeled with fairly simple physics that undergraduate students learn. Temperature rises, volatiles escape, brightness increases. It's a curve, a smooth function, not a step change. 3I Atlas didn't follow the curve. It jumped from one state to another, instantly. The timing raises questions that are increasingly difficult to ignore or explain away with comfortable assumptions. Why did this transformation happen during total darkness? During the eclipse? If this was simple solar heating, standard come-try behavior, the color change should have been gradual, ongoing, tied directly to the object's decreasing distance from the sun. Instead, it appeared to correlate with the eclipse itself, with the removal of lunar light from the sky, as if the object had been waiting for observers to have their best possible view, or waiting for something else entirely. Waiting for a signal we don't understand. The green color itself tells a story, but not the story we expected. When astronomers observe green in comets, they usually know exactly what they're seeing. Dicarbon, a molecule made of two carbon atoms bonded together. It emits light at a specific wavelength that appears green to human eyes. It's a signature of organic chemistry, of carbon-rich ices being broken apart by ultraviolet sunlight. Comets like C/2022 E3, the green comet that passed through our solar system in 2023, glowed green because of dicarbon in their comas. The spectroscopic fingerprint was unmistakable. But spectroscopic observations of 3I Atlas haven't detected dicarbon. At least not yet. Not in the quantities that would explain that intense green glow. The instruments pointed at this object should see that telltale emission line clearly if dicarbon were responsible for the color. They don't. So what's making it green? Avi Loeb, the Harvard astrophysicist who's become both famous and controversial for his willingness to consider unconventional explanations, suggested an alternative. Cyanide. On August 25, 2025, the Very Large Telescope in Chile's Atacama Desert detected something unusual in the coma surrounding 3I Atlas. Cyanide, specifically the CN molecule, being produced at about 20 grams per second. That's not particularly strange on its own. Comets can produce cyanide. It's part of the complex chemistry that happens when organic-rich ices meet intense solar radiation. What's strange is what happened next. As 3I Atlas moved closer to the Sun, cyanide production didn't just increase. It exploded. The production rate climbed with the inverse of heliocentric distance raised to the power of 9, give or take 1. For those less familiar with mathematical relationships, that's an extraordinarily steep increase. Exponential doesn't even capture it. Most CumTri outgassing follows gentler power laws, typically between 2 and 4. 9 is off the charts, literally outside the range of normal CumTri behavior. It's the kind of spike you'd expect from a chemical reaction hitting a critical threshold, not from the gradual, predictable warming of primordial ice. And cyanide, unlike dicarbon, can produce a greenish glow under the right conditions. If the concentration is high enough, if the excitation mechanism is precisely calibrated, you get green light. The wavelength isn't quite the same as dicarbon's signature, but to a camera capturing broad-spectrum light, to human eyes observing through a telescope, it would look similar. Close enough to be confused. But here's where the story transforms from unusual to deeply strange. Cyanide wasn't the only thing spiking. Nickel. The Very Large Telescope's data showed nickel emissions increasing at the same dramatic rate, about 5 grams per second, climbing as the object approached the Sun following that same impossible power law. Nickel in a comet's coma isn't completely unheard of. Many comets carry trace metals locked in their primitive materials. When solar radiation heats the surface intensely, these metals can be released as vapor. They glow in characteristic wavelengths as they absorb and re-emit light. The problem isn't the presence of nickel. The problem is what's missing: iron. Nickel and iron are siblings in the cosmic abundance table. They form together in stellar cores during nucleosynthesis, get ejected together in supernova explosions, condense together when planetary systems form from the debris. Wherever you find nickel in natural space objects, you find iron. The ratio varies depending on formation conditions, but both are always present. It's one of those reliable patterns in astrophysics, like finding hydrogen wherever you find stars, like finding oxygen in atmospheres with liquid water. 3I Atlas is expelling nickel without any detectable iron. The research team in Chile noted this anomaly in their paper published in late August. They measured nickel emissions clearly, unambiguously. Then they looked for iron using the same instruments, the same methodologies, the same spectroscopic techniques. Nothing. The ratio was so skewed it didn't fit within any framework of natural CumTri composition they could construct. Loeb pointed out something that made the scientific community profoundly uncomfortable, something that resulted in immediate pushback and accusations of sensationalism. There's one place where you regularly see nickel without iron, one environment where this ratio occurs naturally: industrial production, specifically the carbonyl nickel process, a metallurgical technique used to produce high-purity nickel for specialized applications. You heat nickel or in the presence of carbon monoxide under controlled conditions. This forms nickel tetracarbonyl, a volatile compound. Then you decompose it thermally to get pure nickel metal. It's how we make nickel for precision alloys, advanced batteries, specialized equipment that requires extreme purity. It's not how comets make nickel. It's not a process that occurs in nature without deliberate engineering. The suggestion was clear, even though Loeb phrased it carefully as a question rather than a conclusion. Is this anomaly further evidence for a possible technological origin of 3I Atlas? Could we be observing industrial chemistry happening in space? Accidental leakage from processes designed for purposes we can't yet comprehend? Most astronomers rejected this immediately and forcefully. The peer review process, the careful weighing of evidence against known phenomena, all pointed toward natural explanations that must exist even if we haven't identified them yet. Perhaps the iron is present but bound up in dust grains that don't emit light the same way as vaporized metals. Perhaps the surface composition is genuinely unusual, enriched in nickel-bearing minerals through some quirk of formation in its home star system. Perhaps the measurement is slightly off, the interpretation subtly wrong, the data requiring recalibration we haven't performed yet. Perhaps. But the timing of the green activation, the threshold-like behavior, the industrial chemistry signature, they cluster together in a pattern that's increasingly difficult to dismiss entirely. Each piece alone could be explained with enough creativity and enough assumptions. Together, they form a constellation of anomalies. And patterns in anomalies are how we've discovered every major paradigm shift in the history of science. There's one more detail that makes the activation event particularly intriguing, particularly difficult to reconcile with standard CumTri models. The brightness behavior. Data released by the Atlas telescope team, using observations dating back to March 28, 2025, showed something unexpected about how 3I Atlas has been behaving as it approached the inner solar system. When the object was farther than 3.3 astronomical units from the Sun, farther than the distance between the Sun and the asteroid belt, its brightness increased in a specific, measurable way. The cross-section of scattered light, the amount of sunlight the object was reflecting back toward Earth, grew with the inverse of heliocentric distance to the power of 3.9. That's consistent with a dusty surface gradually releasing material as it warms. Then something changed fundamentally when it crossed that threshold distance. The growth rate shifted. The mathematical relationship broke. Instead of continuing to brighten at the same rate, following the same power law, the object's behavior altered dramatically. As if a different process had suddenly taken over. As if a new mechanism had activated. The researchers proposed a physical explanation that fits known CumTri physics. When 3I Atlas was far from the Sun, it was mostly scattering light off its reddish, dusty surface. Passive reflection. As it moved closer and temperatures increased, it began actively releasing small, bright, icy particles. These particles increased the reflectivity of the surrounding coma substantially. The transition from one regime to the other, from passive to active, would naturally cause a measurable change in how brightness scales with distance. That's a reasonable explanation. It fits established physics. It requires no exotic assumptions. But it also means that 3I Atlas underwent a transition at a specific distance from the Sun. Not gradually, not smoothly over a range of distances. It switched modes at a defined threshold. The activation event during the eclipse might have been part of that transition. Or it might have been something else entirely. Another process, another system engaging. We're left with photographs showing a dramatic, instantaneous color change. Chemical signatures that don't fit standard CumTri models no matter how creatively we interpret them. And a brightness curve that suggests the object is responding to solar heating in ways we genuinely haven't observed before. September 7th was the night we stopped being able to explain 3I Atlas using simple analogies to other comets. Using the comfortable frameworks built from centuries of observations. Something about this object is fundamentally different. Whether that difference is natural but rare or artificial and intentional remains an open question that data alone may not be able to answer. But the activation happened. It's not speculation or interpretation. The photographs exist in multiple archives from multiple independent observers. The spectroscopic data is real, peer-reviewed, published. And in the community of astronomers watching this object, tracking its progress, analyzing every photon it emits, a quiet unease is spreading like a slow infection. Because if 3I Atlas is just a comet, it's a comet that systematically breaks rules we thought were fundamental. And if it's not a comet, if there's even a small probability it's something else, then we need to start asking very different questions about what happens when it disappears behind the sun in late October. Questions like, will it come back the same? Will the object that emerges in December be following the same trajectory? Will it still be expelling the same materials at the same rates? Or will something have changed during those 51 days of darkness when no telescope on Earth can observe what it's doing? There's a theory circulating among a small group of researchers. A theory nobody wants to articulate in official channels or published papers. It originated with Omar Elderdy, one of Avi Loeb's collaborators at the Galileo Project. And it's the kind of idea that sounds like pure science fiction until you start examining the timing, until you map out the trajectories and calculate the probabilities. The theory is elegantly simple and profoundly disturbing. 3I Atlas isn't the threat. It's the distraction. Think about how you would design a reconnaissance mission to a planetary system you'd never visited before. A system potentially harboring intelligent life. You wouldn't announce yourself with broadcasts and obvious signals. You wouldn't make a direct, detectable approach to the inhabited world. You'd want to observe without being observed, to gather comprehensive data while remaining hidden, to understand the civilization's capabilities before revealing your presence. But there's a fundamental problem with that strategy. Any civilization advanced enough to detect objects in space, advanced enough to track trajectories and perform spectroscopy, would eventually spot your probe. Telescopes improve with each passing year. Survey systems become more sensitive. Detection networks expand. Eventually, inevitably, you'd be found, detected, analyzed. So what do? How do you solve this problem? You send something obvious, something large and bright and impossible to miss, something that will consume every telescope, every observatory, every planetary defense system's complete attention. Something that generates endless debate and analysis and focused observation. While they're all watching the obvious object, while they're debating whether it's natural or artificial, while they're writing papers and holding press conferences and redirecting their most sophisticated instruments, your actual mission proceeds elsewhere. Unnoticed, untracked, invisible in the shadow of the spectacle. The decoy draws every eye, consumes every resource, and the real operation happens in the darkness beside the spotlight. Elderdy proposed this in a conversation with Loeb, carefully framed as a thought experiment rather than a genuine hypothesis. But thought experiments have a way of becoming testable hypotheses when the data starts fitting too perfectly. When the coincidences accumulate beyond what chance should reasonably produce. And the data around 3I Atlas fits this framework with uncomfortable precision. Consider the object's behavior from this perspective. It's massive, far larger than theoretical models suggested interstellar objects should be. It's bright, easily visible to ground-based telescopes. Amateur astronomers can photograph it with modest equipment. It's moving on a trajectory that brings it close to multiple planets in sequence. Mars, Venus, Jupiter, ensuring maximum observation time from facilities throughout the inner solar system. It exhibits dramatic anomalies, strange chemical signatures, unusual brightness patterns, industrial-grade nickel emissions, all of which generate intensive discussion and analysis and focused attention from the entire astronomical community. It's almost perfectly designed to be noticed, to be impossible to ignore, to dominate every conversation about interstellar objects. But if your goal is to distract an entire civilization's astronomical infrastructure, you need more than just an interesting object. You need precise timing. You need the object to arrive exactly when it will cause maximum focus, maximum resource allocation, maximum debate and controversy. 3I Atlas was discovered on July 1, 2025. Within 24 hours, Its interstellar origin was confirmed through trajectory analysis. By July 3rd, major observatories worldwide were redirecting their instruments, revising observation schedules. The Hubble Space Telescope imaged it on July 21st. The James Webb Space Telescope observed it on August 6th. SphereX captured data from August 8th through 12th. The Very Large Telescope in Chile performed detailed spectroscopy on August 25th. Every major astronomical facility, every space telescope, every planetary defense system capable of tracking fast-moving objects, all watching 3i Atlas. Hundreds of millions of dollars in equipment, thousands of hours of observation time, the focused attention of the global astronomical community, all pointed at one object. So the question becomes unavoidable, uncomfortable, perhaps paranoid. What are we not looking at? What are we missing while we stare at the obvious? Loeb took Elderdy's suggestions seriously enough to implement an actual monitoring program through the Galileo project. The project operates 3 observatories strategically positioned across the United States. 1 in Massachusetts, 1 in Pennsylvania, 1 in Nevada. Unlike traditional astronomical observatories that focus on distant objects in deep space, these facilities monitor the entire sky continuously. They're designed specifically to detect fast-moving objects in Earth's atmosphere and near-Earth space. Unidentified anomalous phenomena in the careful language of government reports. UFOs in the language everyone actually uses and understands. The Galileo Project observatories employ arrays of sensors working in concert. Infrared cameras detecting heat signatures. Optical cameras capturing visible light. Radio detectors monitoring electromagnetic emissions. Audio sensors recording acoustic signatures. Magnetometers measuring magnetic field disturbances. They record everything continuously, building a comprehensive movie of the sky. When something anomalous appears, when something moves in ways that don't fit known aircraft or satellites or meteors or astronomical phenomena, the system automatically flags it for analysis. The data gets processed. Patterns emerge from the noise. Loeb tasked his team with a specific mission. Monitor UAP activity during 3I Atlas's perihelion passage. Look for correlations, statistical anomalies. See if anything else shows up in Earth's atmosphere or near-Earth space while the astronomical community is obsessively focused on the interstellar visitor. Search for the operation hiding beside the spectacle. The monitoring window is precisely defined. October 31st, 2025, when 3I Atlas reaches its closest point to the Sun. That's when the object will be most active, most energetic, most likely to do whatever it's designed to do if it's designed at all. And that's when, if the decoy hypothesis has any validity, whatever else is happening would proceed completely unobserved. The reasoning behind this gets into uncomfortable territory that challenges our assumptions about how advanced intelligences might operate. If a civilization wanted to deploy reconnaissance probes into our solar system, how would they actually do it? You wouldn't launch individual probes from your home system and hope they arrive intact after journeys lasting potentially millions of years. Interstellar space is incredibly harsh. Ionizing radiation, micrometeorite impacts at relativistic velocities, the slow, inexorable decay of any mechanical system over geological timescales. Even the most robust probe would degrade substantially over that journey. Instead, you'd send a mothership, something large enough to carry multiple smaller probes, equipped with sufficient power and propulsion systems to make the journey while protecting its payload. When you reach the target system, you don't just fly through once on a hyperbolic trajectory. You slow down deliberately. You enter a bound orbit around the host star. Then you deploy your probes methodically, sending them to specific locations you want to study. Earth, Mars, Venus, the asteroid belt, Jupiter's intriguing moons, anywhere that might harbor life or resources or scientifically interesting phenomena. A mothership entering our solar system at 3I Atlas's speed, approximately 60 kilometers per second relative to the Sun, would need to brake hard to achieve capture. To transition from a hyperbolic flyby trajectory to a bound elliptical orbit. The most efficient location to perform that maneuver is at perihelion, the closest approach to the Sun, using what orbital mechanicists call an Oberth maneuver. You fire your engines when you're moving fastest, when you're deep in the Sun's gravitational well. The physics of orbital mechanics means you get more delta V, more change in velocity, for the same expenditure of propellant. It's the optimal strategy for any interstellar spacecraft attempting to enter a bound orbit around a star. 3I Atlas reaches perihelion on October 29th. Behind the Sun, hidden from every telescope on Earth. If it were to perform a braking maneuver at that moment, we wouldn't see it happen. We couldn't observe the engine burn or measure the trajectory change in real time. And if it were to release smaller probes during that hidden passage, sending them on carefully calculated trajectories toward the inner planets, toward specific targets of interest, we wouldn't see that either. Not immediately. Not until much later when mysterious objects start appearing in unexpected locations. The probes would be small, dark, radar-absorbent, moving on trajectories calculated to minimize detection probability. They'd arrive at their destinations weeks or months later, long after 3I Atlas had moved on and exited the inner solar system. By the time we realized something else was present, operating in our cosmic neighborhood, it would be far too late to do anything preventive about it. This is where the decoy hypothesis transitions from uncomfortable speculation to legitimate concern that keeps planetary defense specialists awake at night. Because there's a number that makes this scenario more plausible than it has any right to be. 80 years. That's how long it would take an object moving at 3I Atlas's velocity to travel from a base located at 1,000 astronomical units to reach the inner solar system. 1,000 AU is far. Unimaginably far by human standards. But it's not impossibly far. It's within the outer reaches of the Oort cloud. That vast, spherical shell of icy bodies surrounding our solar system like a bubble. An advanced civilization could establish a base there, a way station, an outpost, hidden among literally billions of comets and frozen planetesimals. And we would never know it existed. Our best telescopes can barely detect large objects out to about 10 times the Earth-Sun distance. Maybe 20 astronomical units if we're extraordinarily lucky and the object is unusually bright. Beyond that, space becomes effectively invisible to us. Dark. Unobservable. We assume it's just comets and ice and empty interstellar space because we lack the data to know otherwise. But that's an assumption based on absence of evidence, not on comprehensive surveys proving nothing is there. If there's a base out there, a station or outpost placed by a civilization that mastered interstellar navigation millennia ago, they could watch us for centuries, monitoring our development, tracking our technological progress, waiting patiently until we reached a certain threshold, then sending something in to gather detailed intelligence. 3I Atlas could have been launched 80 years ago, 1945. Right around the time humans first split the atom. Right around the time we developed the capacity to destroy ourselves on a planetary scale through nuclear weapons. That's precisely the kind of threshold that might trigger a response from distant watchers. If watchers exist. If this isn't all paranoid pattern matching on random coincidences. All of this could be overthinking, seeing design where there's only chaos and natural processes. But the Galileo Project's instruments are recording data regardless of our interpretations. The sky monitoring continues every single night. If there's genuinely enhanced UAP activity during late October, if objects start appearing in Earth's atmosphere that don't fit any conventional explanation, If the statistics shift in ways that correlate with 3I Atlas's perihelion passage, the data will reveal it. The sensors don't have biases or preconceptions. They just record what's actually there. And that's what makes the decoy hypothesis at least partially testable rather than pure speculation. If 3I Atlas is just an unusually interesting comet, UAP activity should remain at baseline levels. Random events, misidentifications, the usual noise in detection systems. But if something else is genuinely happening, if the distraction theory has any validity whatsoever, the statistics would shift measurably. More anomalies, tighter clustering in time, patterns that correlate unmistakably with 3I Atlas's perihelion passage and probe deployment windows. We won't have to wait long to find out. The monitoring is happening right now as you listen to this. The data accumulates every single night. By the time 3I Atlas emerges from behind the sun in December, by the time it becomes observable again, we'll know whether anything changed in our skies while we were watching the bright object everyone could see. While we were distracted by the spectacle. The uncomfortable truth nobody wants to articulate publicly is that we're not remotely equipped to detect a sophisticated deception. If an advanced intelligence wanted to observe us covertly while we're distracted by an obvious target, we simply don't have the sensor coverage or analytical capability to catch it. We're barely managing to track near-Earth asteroids that could pose direct impact threats to populated areas. Detecting stealth probes operating in Earth orbit or deploying throughout the inner solar system would require infrastructure we haven't built yet. Capabilities we haven't even funded. Which raises a question that keeps some researchers awake at night, staring at ceiling fans and running calculations. If the decoy hypothesis is correct, if there's genuinely a mothership behind the sun right now preparing to deploy reconnaissance probes throughout the inner solar system, what exactly are we supposed to do about it? The answer, right now, today, is absolutely nothing. We watch. We record. We hope that whatever comes next is either benign or non-existent, because we're not ready for anything else. We don't have response protocols. We don't have defensive capabilities. We don't even have consensus on who would make decisions if something genuinely anomalous occurred. October 1st, 2025. The United States government shut down over budget disputes. Predictable political theater. Over 15,000 NASA employees were furloughed, sent home, offices closed, data pipelines froze, communication channels went dark, scientific work ground to a halt. 2 days later, October 3rd, 3I Atlas made its closest approach to Mars. The timing deserves very careful attention. NASA's Mars Reconnaissance Orbiter carries an instrument called HiRISE. The High-Resolution Imaging Science Experiment. It's designed to photograph the Martian surface in extraordinary detail, capturing features as small as 30 centimeters across from orbital altitude. It can read the serial numbers on rovers, but cameras don't care what they're pointed at. If you redirect HiRISE toward deep space, toward a fast-moving object passing near Mars, the resolution translates differently. 30 kilometers per pixel at the distance 3I Atlas was passing. That's enough resolution to potentially resolve the nucleus, to see whether it's a single solid body or something more complex, to detect structural features if they exist, to answer fundamental questions about this object's true nature. HiRISE took images on October 2nd and 3rd. The camera operators knew the schedule. They'd planned these critical observations weeks in advance, coordinating with international partners. The data was collected successfully, stored in onboard memory, ready for processing and release to the scientific community and public archives. Then the government shut down, and the data stayed locked inside NASA's servers. Inaccessible. Stephen Miller, the White House Deputy Chief of Staff for Policy, gave an interview on October 3rd. During the segment, which aired on national television, he was asked a direct, pointed question by a journalist who'd clearly been following this story. Has the president been briefed about 3I Atlas? The question wasn't random speculation. It came from someone who knew about Loeb's papers, who understood that an interstellar object exhibiting genuinely anomalous properties might warrant executive-level attention. The kind of thing that would normally trigger classified intelligence briefings. Contingency planning. Coordination between agencies and departments. Miller's answer was carefully, precisely non-committal. He acknowledged awareness of the object, but declined to confirm or deny whether presidential briefings had occurred. Standard protocol when you don't want to discuss anything classified in public forums. But the fact that the question was asked at all, that it made it through editorial review and onto national television, suggests that someone in the chain of communication thought it was worth pursuing. Thought the public deserved to know. The timing creates a loop that keeps coming back to haunt you when you examine the sequence carefully. The shutdown began October 1st. The critical Mars flyby happened October 3rd. And on October 4th, just 24 hours after closest approach, certain mainstream media outlets received preliminary briefings from NASA sources characterizing 3I Atlas as an ordinary comet. Nothing unusual. Nothing to be concerned about. No technical reports accompanied these briefings. No images. No spectroscopic data. No peer-reviewed analysis. Just verbal assurances from unnamed officials that everything was normal. Nothing to see here. Move along. Stop wasting resources on this story. NASA's official position, when pressed, is that processing high-resolution data takes substantial time. The images need careful calibration. The team needs to analyze what they're seeing before releasing anything to avoid misinterpretation. This is absolutely standard procedure. Legitimate. Premature release of uncalibrated data can lead to misinterpretation, false conclusions, unnecessary public panic. All of that is completely true and reasonable. It's also true that rushing out verbal characterizations to media outlets before completing any analysis seems strangely inconsistent with the careful, methodical approach NASA normally takes. If the data genuinely needs days or weeks of processing before it can be properly interpreted scientifically, why brief media outlets 24 hours after collection? Why not wait until the full analysis is complete and defensible? Loeb's response to questions about the shutdown and data delay was characteristically pointed. When people asked him whether the delay in releasing data might indicate some kind of conspiracy to hide evidence of extraterrestrial intelligence, his answer became an instantly quotable soundbite that spread across social media. The delay is not the signature of extraterrestrial intelligence. It's more a signature of terrestrial stupidity. It's an excellent line. Perfectly crafted. It frames the entire situation as bureaucratic incompetence rather than any kind of malicious intent or organized cover-up. And bureaucratic incompetence is certainly the simpler explanation. The one requiring fewer extraordinary assumptions. The one that aligns with Occam's razor. But timing is a stubborn thing. It exists independently of our interpretations. It doesn't care about simplicity or philosophical elegance. It just sits there in the data, refusing to be ignored or explained away. The European Space Agency faced no shutdown, no political drama. Their Mars orbiters, the ExoMars Trace Gas Orbiter and Mars Express, both captured images of 3I Atlas on October 3rd using cameras designed for surface mapping. ESA released those images publicly on October 7th. For days of processing, which is completely reasonable for an unexpected target using instruments optimized for different purposes. The images show a fuzzy white dot against the black of space. Not much detail. The cameras weren't designed for observing distant objects in deep space, but they released what they had. Raw. Preliminary. Uncalibrated. Here's what we saw. Make of it what you will. Transparent. Scientific. NASA's approach was fundamentally different. Silence during the shutdown, then verbal briefings to select outlets characterizing the object without showing any actual data. Then continued silence about the high-rise observations, which should have provided significantly better resolution than anything ESA captured. The Chinese Space Agency operates Tianwen-1, another capable Mars orbiter with imaging systems. The United Arab Emirates operates the Hope orbiter. Both were in position to potentially observe 3I Atlas during the Mars flyby. Neither has released any data publicly. Whether they captured useful images, whether they're analyzing what they found in classified facilities, whether they're sharing that analysis with other agencies through back channels, all of that remains completely unknown. Radio silence is sometimes a choice. Sometimes it's protocol. And sometimes it's the sound of people trying desperately to figure out what they're looking at before they tell anyone else. Before they trigger reactions they can't control. There's a well-documented pattern in how governments handle information that doesn't fit existing frameworks. Information that challenges fundamental assumptions. First comes confusion, genuine uncertainty about what the data means. Then comes classification, restricting access while analysts try to understand implications. Then comes the careful, controlled drip of sanitized details designed to manage public response, to prevent panic. It's not necessarily malicious or conspiratorial. It's the institutional immune system protecting itself from chaos, from paradigm collapse. If 3I Atlas is just a comet, if the data shows absolutely nothing unexpected, then the delay is completely meaningless. Processing takes time. Shutdowns cause disruption. Everything will be released eventually through normal channels. And it will all make perfect sense. All the concern will look foolish in retrospect. But if the data shows something that can't be easily explained, if high-rise captured images that raise more questions than they answer, if there's structure or geometry or features that don't fit natural formation models, then the silence becomes strategic rather than bureaucratic. You don't release genuinely confusing information during a government shutdown when you can't provide proper context. Can't coordinate messaging across agencies and departments. Can't prepare the scientific community for what they're about to see and debate. You wait. You analyze privately. You build consensus among experts. And then you release it in a carefully controlled way that minimizes disruption and manages interpretation. Or you never release it at all. You classify it at levels that ensure it never reaches public archives. And you let people assume the data was unremarkable. Nothing worth seeing. Just another comet. Amateur astronomers tried desperately to fill the gap. To provide the images NASA wasn't releasing. One particularly dedicated observer operating under the name Dobsonian Power posted images captured on October 3 claiming to show unusual structural features in 3I Atlas. The images spread rapidly across social media platforms. Thousands of shares within hours. Hundreds of comments. Is this evidence of artificial structure? Is this the proof we've been waiting for? Analysis by professional astronomers poured cold water on the excitement almost immediately. The images were captured using solar observation equipment, not deep space imaging tools. Heavy digital enhancement had amplified noise into apparent structure. Atmospheric turbulence, optical aberrations, processing artifacts, all combining to create patterns that looked meaningful to untrained eyes but weren't actually real. It's a reminder of something important. We're desperate for clarity. We want answers. We want high-resolution images that show us definitively what this object actually is. And in the absence of official data, we'll accept amateur observations. Wishful thinking. Anything that fills the terrifying void of uncertainty. The void exists because the people with the best instruments, the organizations who actually have the data we need, aren't sharing it. Whether that's due to incompetence or intention, the effect is identical. Uncertainty. speculation, growing unease rippling through communities that follow this story. What did HiRise actually see? The camera has the resolution to potentially answer fundamental questions about 3I Atlas. Questions that would settle this debate one way or another. Is it a single solid nucleus or a loose rubble pile aggregate? Does it show surface features consistent with natural formation processes? Is there any geometric structure? Any components or arrangements that don't fit the standard model? Those images exist somewhere in NASA's data systems right now. The raw files are stored on servers. Photons from 3I Atlas struck the detector. Information was captured and encoded. The answers to at least some of our burning questions are sitting in a database somewhere, waiting to be processed and released, or waiting to be buried. Days pass, then weeks. The government shutdown ends. Operations resume. Furloughed employees return to work. And still, no HiRise images of 3I Atlas appear in NASA's public archives. You can check yourself. The HiRise team maintains a searchable database of all observations. You can search by date, by target, by coordinate. The October 2nd and 3rd observations of 3I Atlas should be there. Indexed. Available. They're not. Or they're not tagged in any way that makes them easily findable. Or they're undergoing extended processing for reasons nobody will explain publicly. Radio silence from the highest resolution camera that had the clearest possible view of the most interesting interstellar object to visit our solar system in recorded history. Maybe it's nothing. Maybe the bureaucracy is just slow. Maybe we'll see the images eventually in a few more weeks or months, and they'll show exactly what we expect to see. A slightly irregular comet nucleus, surrounded by a dusty coma. Nothing unusual whatsoever. Case closed. Vindication for the skeptics. Embarrassment for anyone who suggested otherwise. Or maybe the silence itself is the signal. Not evidence of conspiracy, but evidence of profound confusion. People trying desperately to understand what they're looking at before they show it to a world that isn't ready. Scientists arguing intensely over interpretation. Administrators carefully weighing the risks of releasing data that might be catastrophically misunderstood. The shutdown gave everyone a convenient excuse for the delay. Blame the politicians. Blame the budget crisis. Blame anything except the possibility that something genuinely anomalous was observed. But the shutdown didn't stop ESA from releasing their images. It didn't stop amateur astronomers from posting their observations and analyses. It only stopped NASA, the agency with the best data, the highest resolution imagery, from sharing what they found. And that absence, that specific silence, speaks far louder than any official statement could. If you're still with me, if you've followed this investigation this far, I need you to do something critical right now. Hit that like button. This isn't about algorithm games. This is about signal-boosting information that matters. Information that could change how we understand our place in the universe. And when you get to the absolute end of this presentation, comment the words "I'm awake" so I know you went the full distance. So I know you're one of the people actually paying attention. Jason Wright sits in his office at Penn State University. A tenured astronomer with credentials that can't be easily dismissed or hand-waved away. He runs a blog called AstroWrite where he discusses his research, comments on new papers, engages thoughtfully with the broader astronomical community. In late July 2025, he wrote a post titled "AVI and 3I Atlas." The post was not kind, not gentle, not diplomatically worded. Wright went through Loeb's analysis point by methodical point, systematically dismantling arguments about image smearing, coma detection, spectroscopic interpretation. He called out what he characterized as fundamental misunderstandings of how astronomical observations actually work. The tone was exasperated, The kind of deep frustration that comes from watching someone with a massive platform and significant influence make claims that simply don't hold up to proper scrutiny. One particular section stood out starkly. Wright quoted directly from Loeb's preprint paper. The line about how the fuzz observed around 3I Atlas is inconclusive given the motion of the object and the inevitable smearing of its image over exposure time. Then Wright explained precisely why that's completely wrong. Why it reveals a fundamental misunderstanding of technique. Comet astronomers don't track stars when observing comets. They track the comet itself. The telescope follows the object across the sky, keeping it centered perfectly in the frame. Stars smear into streaks. The comet stays sharp and clear. That's absolutely basic technique. The kind of thing any planetary scientist learns in the first year of graduate school. Fundamental observational astronomy. Loeb dismissed observations of 3I Atlas's coma by claiming they were artifacts of tracking error or motion blur. But the observers weren't making errors. They were doing their jobs correctly, following standard protocols. The coma is real, observed by multiple independent teams. Wright's conclusion was devastatingly blunt. This is sloppy work, beneath the level expected of an undergraduate. Then he did something almost unprecedented in professional astronomy. He assigned it an actual grade. The blog post included a detailed grading rubric, filled out as if Loeb had submitted a homework assignment that failed to meet basic standards. The grade was failing. This is the nuclear option in academic discourse. You don't publicly humiliate a colleague like this unless you believe the stakes are high enough to justify breaking professional norms. Wright wasn't attacking Loeb for being wrong. He was attacking him for being wrong in ways that undergraduate students shouldn't be, while using a massive platform to spread those errors to millions of people who lack the training to recognize them. The frustration stems from asymmetry. It takes hours to carefully debunk a claim that takes seconds to make. By the time Wright wrote his detailed rebuttal, Loeb's original paper had already been shared thousands of times, quoted in dozens of news articles, embedded in public consciousness as Harvard professor says might be alien. The correction never travels as far as the claim. Truth moves slower than spectacle. Other astronomers joined the chorus, though most chose quieter venues. Matthew Knight from the United States Naval Academy pointed out that every single anomaly Loeb attributed to 3I Atlas had precedent in naturally occurring comets. Unusual gas ratios? Comet Hale-Bopp showed similar chemistry. Asymmetric outgassing. Dozens of comets produce jets from localized active regions. The green activation, entirely consistent with CN and C2 molecules being released when the object crossed specific temperature thresholds. Each piece of evidence Loeb presented as extraordinary had ordinary explanations if you actually understood cum-tri physics. But Knight acknowledged something crucial. The scientific community bears responsibility for public confusion. When astronomers stay silent, when they refuse to engage because they don't want to amplify fringe theories, they create an information vacuum. Into that vacuum flows speculation, misunderstanding, the assumption that silence equals agreement or suppression. The solution isn't mockery or public grading. It's patient, accessible explanation, taking the time to show people why the extraordinary claims don't hold up. Building scientific literacy so the public can evaluate evidence themselves rather than trusting whichever voice sounds most confident. That's hard work. It doesn't generate headlines or social media engagement. It requires translating complex physics into language anyone can understand without oversimplifying to the point of inaccuracy. Most scientists aren't trained to do this. They're trained to write papers for other specialists, to present at conferences where everyone shares baseline knowledge, to communicate within their field rather than beyond it. Loeb is exceptional at public communication. He writes clearly. He gives compelling interviews. He frames ideas in ways that capture imagination. Those are genuinely valuable skills that most scientists lack. The problem emerges when those communication skills outpace the rigor of the underlying analysis. When the narrative becomes more important than whether the narrative is actually supported by evidence. When you're so committed to a conclusion that you start dismissing data that doesn't fit. The scientific civil war over 3I Atlas isn't really about this one object. It's about methodology, about standards, about what constitutes sufficient evidence for extraordinary claims. It's about whether science should take seriously every possibility, no matter how unlikely, or whether prior probability matters. Whether we should consider alien technology when natural explanations remain viable. These are deep questions without clear answers. Reasonable people disagree about where to draw lines between open-mindedness and credulity, between skepticism and dogmatism. What's not reasonable is the personal attacks, the accusations of bad faith, the assumption that disagreement equals either stupidity or conspiracy. Wright genuinely believes Loeb is doing sloppy science that damages public understanding. Loeb genuinely believes the establishment is too quick to dismiss unconventional ideas, too invested in existing paradigms to consider genuine anomalies. Both might be partially right. The data will ultimately arbitrate. Not opinions, not credentials, not who can write the most scathing blog post. Observations of 3I Atlas will continue. Measurements will accumulate. By early 2026, we'll have a complete dataset spanning the object's entire passage through the inner solar system. Either the anomalies will resolve into natural phenomena we understand, or they'll deepen into patterns that genuinely can't be explained by conventional physics. Either way, the answer lies in the data, not the debate. Until then, the civil war continues. Scientists arguing in papers and blog posts and conference presentations. The public watching, confused about who to trust, uncertain whether they're witnessing genuine scientific controversy or coordinated suppression of uncomfortable truths. And 3I Atlas continues its journey, utterly indifferent to the human drama unfolding in its wake. December 19, 2025. The moment of truth arrives. 3I Atlas emerges from behind the sun, its trajectory recalculated by every major observatory on Earth. Telescopes from Chile to Hawaii to space-based platforms lock onto the object, tracking its position with unprecedented precision. Within 72 hours, the new orbital elements are published. The analysis is unambiguous. The trajectory has not changed. No deviation from the path predicted by pure gravitational mechanics. No evidence of thrust, no course corrections, no maneuvers. The object continues outbound exactly as a natural comet should, following Newton's laws with mathematical perfection. For the skeptics, this is vindication. An object performing an Oberth maneuver would have shown measurable trajectory changes. 3I Atlas didn't. Therefore, it's natural. Case closed. The anomalies were interesting, worthy of study, but ultimately explainable through conventional physics once we gathered enough data. The dark forest remains theoretical. The mothership was a comet all along. Humanity can return to its comfortable assumption that we're alone, that the universe is vast and empty, that intelligence is so rare we might be the only example for thousands of light years in any direction. But for others, the unchanged trajectory proves nothing. A sufficiently advanced propulsion system could perform maneuvers without detection. Engines that don't produce visible exhaust. Thrust mechanisms we don't understand. Or perhaps the object completed its mission without needing to alter course. Perhaps it deployed what it needed to deploy during that 51-day window when we couldn't observe. Perhaps it dropped small probes, released monitoring equipment, scattered sensors throughout the inner solar system, and those objects are now drifting on trajectories we won't notice for months or years. Perhaps the mothership never intended to stay. Its job was delivery, and delivery was accomplished behind the sun where we couldn't witness the operation. The Galileo project releases its findings in late December. Data from 3 observatories monitoring UAP activity during 3I Atlas's perihelion passage. The results are inconclusive. UAP detections did increase slightly during late October, but the statistical significance is marginal. Could be random variation. Could be observer bias, people looking harder and therefore seeing more. Could be atmospheric phenomena coincidentally clustering during that specific time frame. Or it could be exactly what the decoy hypothesis predicted. Enhanced activity while everyone watched the obvious object. The data doesn't definitively prove anything. It just adds another layer of uncertainty to an already murky situation. By January 2026, 3I Atlas is fading from view, moving outbound past Jupiter's orbit, heading back toward interstellar space. It will leave our solar system entirely by late 2026, accelerating as the sun's gravity weakens, eventually reaching the same 60 kilometers per second velocity it entered with. Within a few years, it will be too faint to observe even with the most powerful telescopes. It will vanish back into the darkness between stars, carrying whatever secrets it holds beyond our ability to ever verify. The scientific papers continue to appear through 2026. Detailed analyses of composition, trajectory, outgassing patterns. Each paper adding pieces to a puzzle that never quite forms a complete picture. The consensus gradually solidifies around natural origin with unusual but explicable characteristics. A comet from another star system, enriched in certain elements, depleted in others, following a trajectory that happened to align with our planetary plane through pure chance. The probabilities were low, but low probability events happen constantly in a universe vast enough to try every combination eventually. We noticed 3I Atlas because it passed close enough to detect. Thousands of other interstellar objects probably pass through unnoticed every century, too distant or too faint to register in our surveys. Loeb publishes a book in early 2026. Interstellar, Our Future Beyond Earth. It uses 3I Atlas as a jumping-off point to discuss humanity's eventual expansion into space, the search for extraterrestrial intelligence, the need to take seriously the possibility that we're being observed. The book becomes a bestseller. Critics call it speculative, scientifically unsound, dangerously irresponsible in promoting ideas without sufficient evidence. Supporters call it visionary, necessary provocation, exactly the kind of thinking humanity needs if we're going to survive our transition to a spacefaring civilization. The debate never fully resolves. It just fades as public attention moves on to other crises, other discoveries, other controversies. 3I Atlas becomes a footnote in astronomical history. The third confirmed interstellar object. Unusual chemistry. Subject of significant debate in 2025 to 2026. Ultimately classified as natural origin with high confidence, though certain anomalies remain unexplained pending further theoretical development. But in classified briefings, in conversations that never get recorded, in meetings between intelligence officials and defense strategists, 3I Atlas occupies a different role. It's a test case, a reminder that our detection systems have blind spots, that our analysis frameworks might not be adequate for genuinely novel phenomena, that the question of whether we're alone carries implications for national security, planetary defense, the entire structure of assumptions on which human civilization is built. Protocols get updated. Contingency plans get drafted. Resources get allocated to monitoring systems and sensor networks, justified through budget lines that never mention alien technology explicitly. Because even if 3I Atlas was natural, even if every anomaly had conventional explanation, the experience revealed how unprepared we are for the alternative. How fragile our certainty really is. How quickly consensus can fracture when confronted with data that doesn't fit comfortable categories. The next interstellar object will be tracked more carefully. analyzed more thoroughly, subjected to scrutiny that 3I Atlas only received after it was already passing through. We've learned. We've adapted. We're better prepared now than we were in July 2025. Or at least that's what we tell ourselves. That's the comfortable narrative. We saw something strange, we studied it, we learned from it, we moved forward. The system worked. Science functioned as intended. Uncertainty was reduced through careful observation and analysis. But deep in the night, when you really think about the timing, the probabilities, the clustering of anomalies, a different question emerges. One that doesn't get asked in official channels or published papers. What if we got it wrong? What if the comfortable explanation, the natural origin conclusion, is exactly what we wanted to find because the alternative is too destabilizing to accept? What if something genuinely unprecedented passed through our solar system, demonstrated capabilities we don't understand, accomplished objectives we can't perceive, and then left satisfied that humanity isn't ready yet? Isn't advanced enough yet? Isn't worth the risk of direct contact? What if we're living in the aftermath of first contact, and we dismissed it as a comet because admitting anything else would shatter every assumption about our place in the universe? You can't prove a negative. You can't definitively show that 3I Atlas wasn't technology disguised as natural phenomena. The absence of evidence isn't evidence of absence when you're dealing with intelligence that might be thousands or millions of years more advanced than us. Intelligence that would know exactly how to appear natural to observers with our level of capability. That would understand our detection methods well enough to operate just below the threshold of what we'd consider definitive proof. The universe is vast. Unimaginably, incomprehensibly vast. Billions of galaxies, each containing billions of stars, each potentially hosting planets where life might emerge. The mathematics suggest we should not be alone. The silence suggests otherwise. And into that silence, into that vast empty cosmos, came an object from another star. It appeared during an eclipse, changed colors instantaneously, expelled industrial-grade nickel without iron, produced cyanide at rates that violate normal come-try behavior, showed activation patterns consistent with deliberate design, followed a trajectory that aligned with our planetary plane against astronomical odds, passed multiple planets at optimal observation windows, then disappeared behind the sun at the exact moment when maneuvers would be undetectable. Each piece alone is explainable. Together, they form a pattern. Whether that pattern represents intelligence or coincidence, design or chaos, visitation or natural formation, the answer matters more than almost any question humanity has ever confronted. Because if we're alone, if 3I Atlas was natural, then the universe is empty and we're free to expand without interference, without competition, without the need to hide or fear what's watching from the darkness. But if we're not alone, if something came, observed, and left, if we're being monitored by civilizations that know we're here while we fumble in ignorance trying to determine if they exist, if the dark forest is real and we've already lit our campfire, already announced our presence through a century of radio broadcasts and deliberate transmissions into space, if we're living on borrowed time, counting down to a moment when the watchers decide we've become enough of a threat to require elimination, then every day of silence is a gift. Every night without contact is another chance to prepare. Another opportunity to build the capabilities we'll need when the universe stops being quiet. When something responds to our broadcasts. When the next interstellar object arrives and doesn't bother hiding what it really is. 3I Atlas is gone now. Fading into the distance. Becoming just another point of light among billions. Indistinguishable from stars except to those who know exactly where to look. It's out there somewhere, traveling through the void between solar systems. Maybe it's transmitting data back to whoever sent it. Maybe it's recording everything it observed, building a comprehensive intelligence report about this unremarkable yellow star, and the primitive civilization that barely noticed its passage. Maybe it's completely inert, just ice and rock following gravitational paths determined billions of years ago. We don't know. We may never know. And that uncertainty, that fundamental inability to say with absolute confidence what 3I Atlas really was, represents either the greatest mystery of our generation or the most mundane misunderstanding. A question that will haunt humanity until we develop the technology to visit interstellar objects ourselves, to land probes on their surfaces, to drill into their structures and analyze their composition with instruments sensitive enough to distinguish between natural formation and deliberate construction. That day will come eventually. Decades from now, perhaps centuries, humanity will possess the capability to intercept interstellar visitors, to chase them down, to answer definitively whether we're seeing travelers from impossible distances or ordinary debris from stellar formation. Until then, we watch, we wait, we wonder whether the next discovery will be the one that finally proves we're not alone, or whether we'll spend generations staring at an empty cosmos, seeing patterns that aren't there, desperately searching for evidence of companionship in a universe that refuses to answer back. The story of 3I Atlas isn't finished. It's just paused, waiting for the next chapter, the next object, the next anomaly that makes us question everything we thought we understood. And when that moment comes, when something appears in our sky that can't be explained away with comfortable assumptions and conventional physics, we'll look back at 3I Atlas and wonder if this was the warning we ignored, the signal we dismissed, the moment when contact was offered and we were too blind, too stubborn, too committed to our assumptions to recognize it for what it really was. Sleep well tonight. Tomorrow, the universe continues, indifferent to our theories, unconcerned with our debates. Objects drift through space following trajectories determined by forces we understand and forces we don't. Some are rocks, some are ice, and some, perhaps, are something we don't have words for yet. Something we won't recognize until it's too late to matter. 3I Atlas passed through. Came, it was observed, it left. Whether it was alone or whether it left something behind, whether it was the first visitor or one among many, whether it marked the beginning of something new or the end of our cosmic isolation, only time will reveal. And time, as always, is patient, far more patient than we are. It will wait as long as necessary for us to understand what we witnessed. Or it will wait forever, keeping its secrets, leaving us to wonder in the darkness we've only just begun to explore. If you made it this far, you're part of the few who actually pay attention. Comment, "I'm awake" below. Hit that like button to boost this message to others who need to hear it. Subscribe so you don't miss what happens next when 3I Atlas reaches the outer solar system and whatever happens in December 2025. Watch the next video appearing on your screen now. Because the story doesn't end here. It never does. The universe has more secrets than we have questions. And the answers, when they finally come, might be more terrifying than the silence ever was.